Good morning, children.
Good morning, ma'am.
Good morning.
Good morning.
Good morning, children. I've shared my screen. Is it visible? Yeah?
Yes, ma'am.
Okay. All right. Now, raise your hand. Use the raise hand option. Raise your hand, children. Those of who have watched the recordings. No. 1 second. Those of you who have watched the recordings which are shared on polynomials. If you have watched the recordings, raise your hand. If you have not watched, do not raise. I had shared some videos on polynomials. Okay, so Blessy, Aragamai, Blessy has watched. Okay. Aragamai, Laksha, Srivatsan, and Swati, you have not still watched the recordings which are shared on polynomials. All right. Okay. So please watch it. So from the videos, you would have got this definition for a polynomial. What is a polynomial? What is a polynomial? It is an algebraic expression. A polynomial is an algebraic expression. In which the variables involved have non-negative integral powers. All right. Now let us understand the meaning of this phrase. All this is explained in the videos, children. Today, I'm just recalling what you have seen in the videos, what you've seen and understood in the videos, and then you'll be taking a small test based on the introduction to polynomials. So we'll come to that after the discussion. We'll come to the test after the discussion. So non-negative integral powers. So you know, this is how we represent the numbers on a number line: 0, -1, -2, -3, and so on. 1, 2, 3, 4. These are positive integers. These are meaning it goes on, children. It's not only this, you know that. So these are negative integers. Now the 0 is neither positive nor negative. The 0 is neither positive nor negative. So when we say non-negative meaning it should not be negative, that's all. Non-negative. See, I'm trying to clarify that non-negative does not mean positive only. Non-negative means it should not be negative. It should not be negative means all this is gone. So 0 and the collection of all the positive integers, which means whole numbers. See, take away the negative integers, -1, -2, -3, -4. So take away the negative integers because it should be non-negative. It should not be negative. So take away all the negative integers. So you're left with 0 and the positive integers. So these are non-negative. 0 and the positive integers are non-negative. If you take away the collection of negative integers, what is remaining is the collection of non-negative integers. So 0 and all the positive integers form the collection of non-negative integers. In simple words, they are whole numbers. Integral means of integers. So basically non-negative integral powers, meaning power should be a whole number. Power should be a whole number. So it can be 0, 1, 2, 3, 4, 5, 6, and so on. It cannot be a fraction. The power should not be a fraction. That's it. Okay, let me not tell you the what it should not be. The power should be a whole number. If the power is a whole number, then it is a polynomial. Otherwise, it is not a polynomial. So a polynomial is basically an algebraic expression. And this expression may have one or more variables. This expression may have one or more variables. You must look at the powers of the variables involved. We will be dealing with polynomials only in one variable. In your syllabus, we'll be dealing mostly with polynomials in one variable x or one variable y or one variable z. But an algebraic expression can have one or more variables. So when you're given an algebraic expression, you must look at the powers of the variables x, y, z. If they're all whole numbers, then that algebraic expression is a polynomial. So let's just take an example. Now we'll just list out some algebraic expressions. Supposing 4x to the power 4 minus root 7 x cubed plus 5x minus say like 3 by root 5. Now the question is this an algebraic? See, anything which is made up of constants and variables is an algebraic expression. Any expression made up of constants and variables is an algebraic expression. Now this one is an algebraic expression because we can see the variable x with different powers. We can see there's only one variable x. There is only one variable x. So you can see the variable x and some constants. Constants are those which have fixed values like 4, root 7. They all have fixed values, 5, 3 by root 5. These have fixed values. X is the variable here. So this expression is made up of constants and the variable x. So it is an algebraic expression. Algebraic expression means if it is made up of constants and variables, it is an algebraic expression. You don't have to check the powers or anything. Now, if this algebraic expression should be called a polynomial, then you will have to look out for the powers of the variable involved here. So the variable is x. X is the variable. Now check the power of x. See, now the different terms of this algebraic expression are, the different terms are 4x to the power 4 minus root 7x cubed plus 5x minus 3 by root 5. These are the different terms of the algebraic expression. So this algebraic expression has 4 terms. This algebraic expression has 4 terms. You must write the terms along with the sign. You must write the terms along with their signs. Now these are the different terms. So this algebraic expression has 4 terms. And it has only one variable x. The power of x may be different, but there's only one variable x. You don't see y, z or any other variable. Now look at the first term. Look at the variable x. Look at only that x. Don't look at the number, the numerical coefficient. Okay, the numerical coefficient of x to the power 4 is 4. The numerical coefficient of x to the power 4 is 4. The numerical coefficient of x cubed is minus root 7. The numerical coefficient of x is plus 5 and the constant is minus 3 by root 5. Minus 3 by root 5 is the constant. Now we are not concerned about the coefficient. We are only concerned about the power x. We are not concerned about the coefficient. We are concerned only about the power x. Its power is 4. It is a whole number. It is a whole number. The power is a whole number. X in the second term. In the first term, the power of x is 4 and 4 is a whole number. In the second term, the power of x is 3 and 3 is a whole number. In the third term, the power of x is 1 and 1 is a whole number. And this is the constant. This is the constant. There is no x there. But if at all you want to write an x here, it is x to the power 0. Because you know x to the power 0 is 1. X to the power 0 is 1. So if you want to fix x to the constant term, it is x to the power 0. And clearly 0 is a whole number. 0 is a whole number. See, it's a constant. You don't see x there. But if you want to understand why this qualifies, you can write x raised to the power 0. Because anything to the power 0 is 1. And here also you can see that x is raised to the power 0 and 0 is a whole number. So in all the terms, you must check the powers of x in every term of the algebraic expression. This algebraic expression has 4 terms. Every term we checked. We looked at x and its power, x its power, x its power, x its power. Everywhere the power of x should be a whole number. Even in one place, if it is not a whole number, it is not a polynomial. It's an algebraic expression. In any case, it is an algebraic expression. Whether the powers are whole numbers or not whole numbers, whatever they are, it is an algebraic expression. But if it should be called a polynomial, then everywhere in every term, the power of x should be a whole number. Now here it is a whole number everywhere. Therefore, the given expression is a polynomial. Do we understand this, children? Yeah, kindly respond.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
All right, children. Fine. Next is about the now this you will not have, but I'll just tell you. Now, supposing an algebraic expression has more than one variable, like yeah, and then the earlier example I wrote, you could see the constant. I think the constant was 3 by root 7 or whatever. Don't see now this root 7 is not a whole number. Don't worry about all that. You should only be concerned about the variable and its power, nothing else. The others can be anything. We are concerned only about the variable and its power. Nothing else we are concerned about. Look at this one. Now, this one is an algebraic expression. Simply when you look at it, okay, x, y, some constant, okay, algebraic expression. Does x, does y. There are some variables x, y, z and constant, so it's an algebraic expression. Now, is this a polynomial is the question. Yeah, now you can do it faster because you know it. X, its power is 3 whole number. Y, its power is 1 whole number. Z, its power is 1 whole number. The rest of it, this root 5, all this does not affect the expression to be called a polynomial. These things do not affect. Don't be concerned about this. Be concerned only about the variable and its power. X variable, power 3 whole number. Y variable, power 1 whole number. Z variable, power 1 whole number. Everywhere whole number. So it is a polynomial. It is also an algebraic expression. Not that now it is not an algebraic expression. Now it's only a polynomial. Not like that. It is now this algebraic expression is also a polynomial. So in the video, you would have come across the terms monomial, binomial. Tell me the others. Those who watched the videos. Monomial, binomial.
Trinomial.
Trinomial and?
Polynomial.
No, that's what. Only these 3. Polynomial is a general term. Monomial, binomial, trinomial. I might have also explained biquadratic, I think. Biquadratic polynomial. Monomial, binomial, trinomial, biquadratic polynomial. Okay, so what's a monomial?
It has only one term in it.
Yeah, a monomial is a polynomial with only one term. A monomial is a polynomial. See, if it should be a monomial, it should be a polynomial first. Now, supposing root x. This is not a monomial. Because what is root x? Root x means x to the power half. Root x means x to the power half. And what's the power of the variable? 1/2, which is not a whole number. So this one is not a polynomial at all. Then it is not a monomial. Simply because there is one term, you cannot say, okay, yeah, it is a monomial because it has only one term. It's not like that. For an expression to be called a monomial, binomial, or trinomial, it should first be a polynomial. See, we are used to, we have maybe understood like this polynomial means many terms. Maybe. From the answers I got some time back, that's what I understand. You might have understood that is in your junior classes that polynomial means many terms because poly means many. So polynomial means many terms. No. Unlearn that. Unlearn that. Forget it. Say that it's wrong. Tell yourself once. This is how I've understood polynomial. That is wrong. Just feed that in your mind. Don't leave it like that. If you have understood that way, polynomial means an expression with many terms. If you have understood that way, tell yourself, you should talk to yourself. Tell yourself that I've understood that incorrectly. And this is the correct one. A polynomial means an algebraic expression in which, okay, let me put it in simple words. So I'll look at the algebraic expression. I'll look at the variables. I'll look at their powers. If the powers are all whole numbers, 1 second, children. Yeah, children, sorry, I had to answer somebody here. I forgot what I was telling. Yeah, so polynomial, so if you've learned, so now you should learn the correct thing. You should unlearn that. Tell yourself that that's wrong. I've understood it incorrectly. And now tell your mind the correct thing. When you're learning something new for the first time, then and you understand it correctly, so your mind understands it's like that. But in the past, if you've learned something incorrectly, then you have to unlearn that first. Because with most people, what happens, that first learning sticks to your mind. So please unlearn and learn this correctly. A polynomial is not an expression with many terms. Okay, so now look at root x. Root x can be written as x to the power 1/2. The power 1/2, x is the variable, its power is 1/2. And 1/2 is not a whole number. Therefore, root x is not a polynomial at all. Then how can it be a monomial? Because a monomial has to be a polynomial. A monomial has to be a polynomial first. Only if it's a polynomial, it can be called a monomial. A monomial is a polynomial with one non-zero term. A monomial is a polynomial with one non-zero term because you cannot write 0 and say this is a monomial. Then you will write 0 plus 0 and say it's a binomial. Then you will put another 0 and say trinomial. No, 0 is not a monomial. 0 is not a monomial. A monomial is a polynomial with one non-zero term. The term should not be 0. Then what is 0? I'll tell you. We'll come to that later. So root x is not a polynomial. So it cannot be called a monomial. It is an algebraic expression. That's it. It is an algebraic expression. That's it. Similarly, when you have root x plus 5, it has two terms. I'm not saying it does not have two terms. It does have two terms, but it is an algebraic expression with two terms. It is not a polynomial with two terms. It is an algebraic expression with two terms. Why is it not a polynomial? Because the power of x is 1 by 2, which is not a whole number, so it cannot be called a polynomial. It's an algebraic expression. This one is an algebraic expression with 2 terms. It is not a binomial because it is not a polynomial. Because the power of x is not a whole number. Similarly, if you have root x plus, like y plus whatever, like 1 by 2. This one is also, okay, or maybe x square plus root x, one variable, no? So x square plus root x minus 1 by 2, like this. This one has 3 terms. This one has 3 terms. I'm supposing it's cube root here, like this cube root. This one has 3 terms. That doesn't make it a trinomial. That does not make it a trinomial because it has 3 terms. Why it is not a trinomial? Because it is not a polynomial. And why is it not a polynomial? Because in the second term, the power of x is 1 by 3. In the second term, the power of x is 1 by 3. And 1 by 3 is not a whole number. So this expression is not a polynomial, and hence it's not a trinomial. It is an algebraic expression with 3 terms. Okay, so a monomial is a polynomial with 1 non-zero term. A binomial is a polynomial with 2 non-zero terms. It should have 2 terms, and not both the terms must be non-zero terms. See, now if I write y plus 0, this is not a binomial. 0 is not considered as a term. 0 is not considered as a term. Y plus 0 does not make it a binomial. Take away 0, y. Yeah, y is a polynomial because the power of y is 1 and it's a whole number. So y is a polynomial. And the power of y is 1. So it's a meaning it's a, okay, the power of y is 1. It's a whole number. And hence y is a polynomial. Because the power of y is 1, which is a whole number, it's a polynomial. And this so it's now a polynomial. And this polynomial has only one term, y. So it's a monomial. It's a monomial. See, remember when you have to give examples of monomials, it should be a polynomial first with one term. No 0 terms. A binomial is a polynomial with 2 non-zero terms. No term should be 0. 2 non-zero terms. A trinomial is a polynomial with 3 non-zero terms. Not even one term can be 0. All the 3 terms should be non-zero. So, so this is about polynomial, monomial, binomial, and trinomial. Algebraic expression, of course, you understood in the first place. Now this is about the number of terms. This is classification of polynomials based on the number of terms. Like we classify triangles. Like we classify triangles based on the sides and angles. When all the sides are equal, equilateral. When 2 sides are equal, isosceles. When no sides are equal, scalene. If all angles are acute angle triangle. If one angle is right angle. If one angle is obtuse angle triangle. So we classify triangles based on sides and angles. In the same way, we classify polynomials based on the number of terms, what we just saw, based on the number of terms. So 1 term, 2 term, 3 terms. And based on the degree of the polynomial. Based on the degree of the polynomial. This is again a very simple thing, degree. Now, supposing we have a degree of the polynomial, not algebraic expression, degree of the polynomial. All right. So, supposing we write x to the power 5 minus y cube, only one variable x, sorry. I'm used to writing many variables always. Oh my God, again, see. Okay, so now see, I'm reminding you root 7. Root 7 is 7 to the power half, but we are not bothered about this. This is not our concern. Our concern is only x and its power 1 whole number. X, its power 5 whole number. So this one is a polynomial. This expression is an algebraic expression as well as a polynomial. Now the degree of the polynomial is the highest power. What are the, now let me write all the terms. Let me write all the terms. These are the 3 terms. What is the power of x here? 5. What is the power of x here? 1. What is the power of x here? 0. Because I told you, x to the power 0. We have written the powers of x. The powers of x. The power of x is 5. The power of x is 1. The power of x here, x to the power 0 is 0. The highest power is 5. And 5 is the degree of this polynomial. The degree of this polynomial is 5. The degree of the given polynomial is 5. The degree is 5. So look at, see, first you check if it is a polynomial. If the heading is find the degree of the polynomial, then it will be a polynomial. You don't have to check it. If the heading is find the degree of the polynomial or polynomials, then the given will be polynomials. You don't have to check it. So for degree, write out every term. Okay, write out every term and write the power of x or y or z, whichever variable is involved. The highest power is the degree of the polynomial. So the degree of this polynomial is 5. If the polynomial, in case the polynomial has more than one variable, you should know that also. Okay, supposing the polynomial has more than one variable, like it has x square minus xy square minus 5z. Okay, let's write all the terms. X square minus xy square minus 5z plus 11 by 2, which is nothing but x. Now there are many variables, but you can choose anything because you want the power. You can write anything. You can write x to the power 0, y to the power 0, z to the power 0. Anyways, it's going to be 0, so it doesn't matter really. Any variable you choose and you can put. See, if you know that the power of the variable here is 0, that's fine. If you want to know y 0, then write x to the power 0. What's the power of x here? 2. Here there are 2 variables, x and y. So add 1 plus 2, 3. Here there's only one variable and its power is 1. Here it is 0. If the term has more than one variable, if a particular term has more than one variable, then you add the powers. Add the powers. 1 plus 2, 3. Now the highest power is 3. The highest power is 3. So 3 is the degree of this polynomial. The degree of this polynomial is 3. The degree of this polynomial is 3. Now consider this one, x to the power x square y square minus z to the power 7. So here on x square y square, add the powers of only the variables. So x and y are the variables. So 2 plus 2, 4. Z to the power 7, 7. The highest power is 7. The highest sum you've got. Now here this is the sum of the powers. The highest number here is 7. So the degree of this polynomial is 7. The degree of this polynomial is 7. So if the degree of the polynomial is 1, it's called a linear polynomial. If the degree of the polynomial is 2, it's called a quadratic polynomial. If the degree of the polynomial is 3, it's called a cubic polynomial. If the degree of the polynomial is 4, it's called a biquadratic polynomial. We have terms for everything. Biquadratic. If it's 5, it's quintic. It goes on like that. Okay. Now we'll stop here. If the degree of the polynomial is 1, it is called a linear polynomial. If the degree of the polynomial is 2, it's a quadratic polynomial. If the degree is 3, it's cubic. If the degree is 4, it's biquadratic. We'll stop there. For other powers, you don't have to give a special name. You can just say that the degree of the polynomial is 100. That's it. The degree of the polynomial is 100 or whatever. So now we have understood how to classify or how to understand polynomials based on their degree and based on the number of terms they have. Based on the number of terms, we have monomial, binomial, trinomial. Based on the degree, we have linear, quadratic, cubic, biquadratic. And to find the degree, you'll have to write down all the terms one below the other and identify the power of the variable involved. If the term has more than one variable, like 2 or 3 variables, add the powers. And then the highest power. That is the biggest number, the highest number obtained is the degree of the polynomial. The biggest value you get is the degree of the polynomial. Now, constant polynomial and zero polynomial. Constant polynomial and zero polynomial. A zero is called the zero polynomial. Zero is the zero polynomial. It's a special name for zero. Zero is the zero polynomial. All other real numbers other than zero are constant polynomials. All real numbers, all non-zero real numbers. All or every non-zero real number. Every non-zero real number is a constant polynomial. We know real numbers, rational numbers and irrational numbers. Numbers that exist are real numbers. Numbers that exist are real numbers, and real numbers are rational numbers and irrational numbers. All these are constant polynomials except zero. Zero has a special name. Zero is a zero polynomial. Okay. So constant polynomial, every real number is a constant polynomial because it has a fixed value. If you write root 5, root 5 is a constant polynomial because it has a fixed value. It cannot take different values like x, y, or z. Now x can take any value, y can take any value, z can take any value, but root 5 is root 5. The value of root 5 is fixed. Okay, so every non-zero real number is a constant polynomial. And zero is the only zero polynomial. See, the special name for zero. Zero is the zero polynomial. Now coming to the degree of a constant, because when you say polynomial, you should know the degree of the polynomial. When you say polynomial, then what is the degree? Okay. Talking about the degree of a constant polynomial, degree of a zero polynomial. Now, if you ask, zero cannot be called a monomial because what is the definition of a monomial? A monomial is a polynomial with one non-zero term. So zero is not a monomial. An example of a monomial cannot be zero. So these are very sensitive questions. You need to understand the definition clearly. And it is simple.
I'm not sure.
Just a second. Yeah. So the definition of a monomial is a polynomial with one non-zero term. So if you're asked to give an example of a monomial, you cannot write zero because zero looks like one term. But what's the definition of a monomial? A polynomial with one non-zero term. This is not an example of a monomial. So 0 is the 0 polynomial. That's it. Now you can write any constant polynomial for monomial. Like you can write 3, 4, 5, root 7 by 5. All these are constant polynomials as well as monomials because only one term. On one term. And why is it a polynomial? Because 3, supposing x to the power 0, the power of the variable x is 0. It's a whole number, so it's a polynomial. All real numbers are polynomials. Even 0 is a polynomial. But 0 is not a monomial. It is not a monomial. So now coming to the degree of a 0 polynomial and constant polynomial. Now, when you write 5, to know the degree of this constant polynomial, you need the variable. So let's write y. But 5, if you simply write y, it becomes 5y. 5 is different from 5y. You cannot write 5y because 5y is different. So 5y to the power 0. Why? Because that means 5 into 1, which is 5 only. It's 5. So 5 means 5y to the power 0. And what is the power of the variable? 0. What's the power of the variable? 0. So the degree of a constant polynomial is 0. The degree of a constant polynomial is 0. Now you cannot say that you get confused or you forgot. You just take an example. You don't even remember that. If you're asked this question, what is the degree of a constant polynomial? If you're asked this question, what is the degree of a constant polynomial? First, write an example, 10. Okay. Now you want to find the degree. You should know that to find the degree, there should be a variable because the power of the variable only tells you the degree. But there's no variable here. So you put a variable like x. But you know 10 is different from 10x. So you'll immediately put 0 there because x to the power 0 is 1 and 10 into 1 is 10. Now the power of x is 0. And so the degree of a constant polynomial is 0. The degree of a constant polynomial is 0. Now, for 0, the 0 polynomial 0, degree is not defined. Degree is not defined. Is not defined meaning it is not one answer. When do we say it's not defined? If the answer is not unique. Now, when we divide 10 by 2, the quotient is 5. So it's defined. When we divide 11 by 3, so you get some 3, 1, 2 by 3. It's defined. But when you divide something like 13 by 0, see, I'll tell you why it is not defined. When you divide 13 by 0, 13 by 0. So 13, 0, 1s are 0, 0, 2s are is also 0, 0, 3s are 0, 0, 4s are 0. So like you can write so many things, no? Actually, when you otherwise, if you have 11 and 3, 3 3s are 9 only you can write. You cannot write 3 4s are 12. You can write all if you will write only 3 3s are 9. But when you're dividing 13 by 0, 0 1s are 0, 0 2s are 0, 0 3s are 0. See, here in the quotient, you can write so many different numbers. That means you're not getting one answer. You're not getting one number there. You're getting so many different numbers. So that's why we say division by 0 is not defined. Division by 0 is not defined because you cannot get a unique answer. You cannot get a unique answer. One answer you cannot say. So in the same way, when we say the degree of 0 is not defined, that's because you can write 0 as, I'll take a new slide. You can write 0 in so many ways. You can write 0 in so many ways. What are the different ways you can write 0? 0 can be written as 0x to the power 5. It can be written as x to the power 100. It can be written as, like y to the power 575. Or it can be written as z to the power of some 1,45,263. Because everywhere 0 into whatever is 0 only. This is 0. 0 into this is 0. 0 into this is 0. 0 into this is 0. So you can see that 0 can be written in many ways. Because to write or to understand the degree, we need a variable. To understand the degree, we need a variable. That is why we thought, okay, let us fix some variable for 0. Now, the power of x here need not be 0. It can be anything. You can see here, it can be anything because everything will produce 0 only. You're not changing the value. See, everything gives you 0. What is 0 into x to the power 5? 0. 0 into x to the power 100? 0. 0 into y to the power 575? 0. 0 into anything is 0. So then you will say the power of 0 here is 5. Sorry, the degree of 0 here is 5 because x is the variable. X is the variable, its power is 5. So the degree of 0 is 5. Here you will say, in this case, you will say the variable is x, its power is 100. So the degree is 100. The variable is y, its power is 575. So the degree is 575. You can write 0 multiplied by any variable to any power, raised to any power. You can write 0 as 0 into any variable raised to any power, Because anyways, the answer is going to be 0. You do whatever hard work you do, finally you're going to get 0 only. No hard work in writing this example, I'm saying. Whatever you do, you're going to get 0 only. With great difficulty, you write some variable and some big large power, but that into 0 is 0. So we see that 0 can be expressed in different ways. So one of you will write 0 as 0x square, and you will say the degree is 2. Somebody will write 0 as 0 y to the power 100, and you will say degree is 100. And somebody else will say some 500. So like all of you will give different answers. If you're getting different answers, that means the degree is not defined. If it is defined, if the degree is defined, there should be only one answer. All of us should give the same answer. If the degree is not defined, that means all of you are giving different answers. It's possible to give different answers. That is why we say the degree of 0 is not defined. The degree of 0 is not defined. The degree of a constant polynomial is 0. Because if you take 7, 7 can be written only as 7y to the power 0. You cannot write 7 as 7y because 7y is different from 7. But you can write anything without changing the value of what is given originally. You write whatever you want, but you should not change the value which was given originally. Originally, what do you have? 7. How can you write that as 7y? 7y is different. But you can write 7y to the power 0. So the degree of a constant polynomial is 0. The power of the variable. But when you take 0, the number 0 itself, you can write, you can attach any variable with any power. Any power. You can attach any variable with any power because anyways the product is 0. So that's why we say the degree of 0 is not defined. And the most important thing is when you have to, identify if the given expression is a polynomial or not, you need to simplify wherever possible. Let me tell you what that means. Now, supposing you have x to the power 5 minus x to the power excuse me. Now, this one is an algebraic expression. This one is an algebraic expression and it has 3 terms. It has 3 terms. This one is one term. This is the second term. And this is the third term. This is the third term. So this algebraic expression has 3 terms. Now you cannot say it's a trinomial. Now you cannot say it's a trinomial because you don't know if it is a polynomial. You can call it a trinomial only if it is a polynomial. First, you should check if it's a polynomial. And then you can, if it is a polynomial, then you can say it's a trinomial. If it is a polynomial, then you can say, yeah, it is a trinomial. Okay, now let's check. Here, nothing to be simplified. Here you can simplify. X to the power 3 by 2 divided by x to the power half. Because root x means x to the power 1 by 2. So this is nothing but x to the power 3 by 2 minus 1 by 2. Because when bases are same and its division, we subtract the powers. When bases are same and its division, we subtract the powers. So we get x to the power 3 by 2 minus 1 by 2 is 2 by 2, which is 1. Which is 1. So and this one cannot be simplified. It's this itself. So the given expression simplifies to the given expression simplifies. Every expression cannot be simplified. Only if simplification is possible, you're going to do it. Otherwise, no. So here, see here, this term, it was possible to be simplified. So this one is nothing but x to the power 5. This one simplifies to x. And the sign here is minus. So minus x. See, minus x here. X minus x plus root 11. Now look at the terms. 1, 2, 3 terms. X is the variable, its power is 5. X is the variable, its power is 1. So we see that the power of x in the first term and the second term, both are whole numbers. 5 and 1, both are whole numbers. We are not concerned about root 11. Only the variables. X is the variable and powers 5 and 1, whole numbers. So this one is a polynomial. This one is a polynomial. And now you can say it is a trinomial. It's a polynomial and now it's a trinomial. But supposing even after simplifying, you're getting something like 1 by 2. After simplifying, you're getting 1 by 2. Then the power is not a whole number. The power is not a whole number. So it's not a polynomial. If the power is not, after simplifying, if the power is not a whole number, it is not a polynomial. So we started with algebraic expressions. An expression made up of constants and variables is an algebraic expression. Then polynomial. In the algebraic expression, every variable, the variable in every term must have whole number as its power. In the algebraic expression, it will have different terms. Every term might have a variable like x, y, or z. The power of the variable should be a whole number. The power of the variable involved should be a whole number. Then it's a polynomial. If it is a polynomial, then you can call it a monomial, binomial, or a trinomial, depending on the number of terms. Depending on the highest power, that is depending on the degree of the polynomial. Depending on the degree of the polynomial, you can call it a linear polynomial if the highest power is 1. A quadratic polynomial if the highest power is 2. A cubic polynomial if its highest power is 3. And a biquadratic polynomial if its highest power is 4. Other than this, we have a zero polynomial and constant polynomial. Constant polynomial and zero polynomial. Zero is only zero polynomial. Zero is called the zero polynomial and its degree is not defined. Its degree is not defined because you can give different answers for that. And zero is not a monomial because a monomial is a polynomial with one non-zero term. The degree of a constant polynomial, is 0. The degree of a constant polynomial is 0. All right, children. So now what I'm going to do is I'm going to share some images on WhatsApp. I'm sure all of you will have access to a phone. So I'm going to share some images on WhatsApp. Sorry. 1 minute, I just lost the window. Yeah. Okay, so you're going to write down the questions. I'll give you some, I'll tell you how much time I can give you for that. I'll share some images on WhatsApp. You need to write down the question and answer it. Don't just answer it without writing the question. All of you must take down the question, take down one question, answer it. Then the next question, answer it. Next question, answer it, and proceed like that. All right? Yeah. All right, got it, children?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. Just give me 2 minutes. I'll get my phone. I just noticed that I've included one more, concept in the assignment which I prepared. I'll just explain that also, and then you can start answering. So the other thing is, now just give me 5 minutes. I'll finish this. Now, now we know that this one is a polynomial. Okay, this is a polynomial. Now, how do we name polynomials? Polynomials can be named. How do you name it? Like we have names, so you can give a name to this polynomial. So for that, you can use any small letter from A to Z. A, B, C, D, any small letter from A to Z, but don't use X because X is the variable here already. Don't use X because X is the variable here already. Mostly used letters are P, F, Q, mostly P, F, Q. So we can call this one P, and in bracket you must mention the variable involved in the polynomial X. So we can call it P of X. How do you read this? P of X. P of X. So this polynomial is called P of X. You can also call the polynomial Q of X. Q of X. Q of X. Or you can call it R of X. You can call it F of X. But X is X. You cannot say F of Y because this one is the variable. This one represents the variable used in the polynomial. The variable is X. And I told you we will be studying polynomials only in one variable X, Y, or Z. Only in one variable X, Y, or Z. So supposing you have a polynomial like Y cubed minus Y plus 11. Then you can call this F of Y. Because Y, the variable is Y. So you have to mention the variable in the bracket here. And before that, this letter can be anything, but don't put Y. Don't write Y of Y. Your name is different from your surname, right? You cannot, supposing you are like some Sharma or whatever, you cannot name yourself Sharma, right? Your surname is different. You cannot have the same name and surname. Yeah, so you can remember like that. So you cannot call it y of y. This one is y only. Like your surname is fixed. You cannot decide your surname. This is fixed. So like that, this one, what should be written in the bracket is fixed. Whatever is the variable, that only comes in the bracket. That's fixed. This one you can change. This one you can change. Like your name, meaning your parents can name you. There are so many names. You can have different names, but one name finally. But it cannot be the same as this one. It cannot be the same as this one. So that's it. So if you have a polynomial like z to the power 5 minus 4z cubed plus 25. So the variable is z. So in bracket, you have to write z. And you can say f of z. F of z. Now let's understand how to. So this is how we name a polynomial. So when we say f of z, that you're talking about this polynomial. You're talking about this polynomial. This is the name for this polynomial. Now let us find f of 1. F of 1. How to find f of 1? So f of 1 means in the polynomial, in this polynomial, in place of z, see, in place of z, we have written 1, no? So do the same thing. In place of z, use 1. Wherever there is a 1, wherever there is z, say 1. 1 to the power 5 minus 4. Wherever there is z, replace it with 1. See here, z is replaced with 1. So that means in the polynomial, wherever there is z, replace that with 1. So what is it? 1 minus 4 plus 25. 1 minus 4 is minus 3. 25 minus 3 is 22. So we have to be careful when we have to find f of minus 1. Very, very careful. F of minus 1. Very dangerous this minus is. Okay, so it should put you on alert mode. When you see minus, become very alert. Listen to this. So this is the place where most of us can go wrong. I'm not saying because of your ignorance, not that you did not know that. You know it. Still, we have the tendency to make a mistake here. Okay, now minus. So I told you f of minus 1 means in the polynomial, wherever there is z, use minus 1. Now, minus 1 multiplied with itself 5 times. What's the answer? Minus 1. Minus 1 into minus 1, minus 1 into minus 1 into minus 1 into minus 1 into minus 1 is not minus 5. It's not minus 5, it's minus 1. Minus 1. Now, you should not do minus into minus plus. You should not do that. Because you need to first simplify this bracket. You need to first simplify the bracket. Minus 1 the whole cube. What is that? Write that first. Minus 1 the whole cube. Simplify that first. Do not multiply minus into minus and write plus. That's wrong. Now, don't say I did like that and got the same answer like you. See, whether you're getting the same answer, different answer, that is not the question. You should not simplify this first. That's all. You should not do that first. So this bracket has to be simplified. Minus 1 the whole cube. So write this minus 4 as it is. Write this minus 4 as it is in the bracket. What is minus 1 the whole cube? Minus 1. Because minus 1 into minus 1 into minus 1 is minus 1 itself. Plus 25. Now don't ask me, ma'am, you forgot to put the power. Not that I forgot. We have simplified. Minus 1 the whole cube is minus 1. We simplified and we got the result minus 1. It's not that I forgot. We have simplified now. Now in the next step, minus 1. Now minus into minus plus 4. 4 into 1, 4. Plus 25. 29, 28 is the answer. So be careful with the minus. supposing you have -2, like f of supposing -2. I'm just writing something randomly, okay? 4 into -2 the whole square plus say 1. So -2 the whole cube is -8. -2 into -2 into -2 -8. Do not multiply minus into minus and write plus. Don't do that. Write the -4 as it is. Open a bracket. What is the value? What is -2 the whole square? -2 into -2. And that is +4. -2 into -2 is +4. Then +1. Now -8. Now multiply. We have simplified this one. Now multiply. Minus into plus minus. 4 into 4, 16. +1. So this is -24. So -23. All right, children. So now I've actually prepared it carefully, considering whatever we have like understood in today's class. If there's any question beyond what we have understood in today's session, just ignore it. That's all. Just ignore it. Just give me a minute. I'm sharing it. Yes, children. Please check WhatsApp for the images. I've sent 2 images. Start working from the first one. If you have not, I also shared the notes on polynomials. Sometime back, I think 2 days ago, I shared the notes on polynomials. If you have not written that in your book, please leave some pages, 2 to 3 pages. You can leave some extra, no problem. So leave some pages and then start working today's classwork. If you have not started polynomials, please leave 2-3 pages to write on the introduction, which I've already shared on WhatsApp with you. And then start today's work. We'll wind up today's session at 9:45, children, 9:45. So this one, I'll just come back after some 20 minutes, okay? Have you all received the messages?
Yes, ma'am.
Yes,
Okay,
ma'am.
fine.
Yes, ma'am.
Yeah, children. Please copy the question and then answer it. Yeah, I'll come back in 20 minutes, children. Please be engaged. Yes, children, I'm back. What is your status? Have you finished everything or which one are you working? Let me know. Abhishek?
I'm finished, ma'am.
Ma'am?
Yeah. No, one by one. Abhishek finished?
No, ma'am.
Okay. Anirudh? Anirudhan?
No, ma'am.
Okay. Okay. What is your status? If no, then what is the status? Which one are you working? The first image or the second image? Okay. Anugraha? Okay, I'm not able to hear from you, Anugraha. If possible, please text me. Chat on Teams. Bhavishya, finished?
I'm doing, ma'am.
All right. What about Blessy?
Ma'am, I'm doing the second page.
All right. Laksha, Mritsa, Laksha,
Ma'am, second image.
Mritsa,
Finished, ma'am.
finished. Okay. Prenu?
Ma'am, second image.
All right. Sahana?
Ma'am, second image, ma'am.
All right. Srivatsan?
Second image.
All right. Swati?
I'm doing very short answer question. Second.
Okay. Now, all of you, as soon as we end this meeting, you're going to take pictures of your work and share it on WhatsApp with me. If you don't send, I will take it as not done. You don't have to worry if it is right or not right, if it is dirty, don't worry about anything. Just take pictures and share it with me. I'll be happy to see your work, whatever be it. I'll just discuss one answer and wind up the session for today. The first image, we'll see the answer to question number 4. Okay, the first image, answer to question number 4. So you have a polynomial there. It's given it is a polynomial. It is x cubed plus 2x plus 1 by 5. Sorry, minus 7 by 2 x squared minus x to the power 6. Yeah, okay, 6. Now write first one. Blessy, what's the degree of the polynomial? Blessy.
6, ma'am.
Blessy, once again.
6, ma'am.
6. The degree of the polynomial is 6. All of you agree with Blessy?
Yes, ma'am.
Okay, let's just write the polynomial like this. Look at. So it's nothing but the given polynomial is x cubed by 5 plus 2x by 5 plus 1 by 5 minus 7 by 2 x squared minus x to the power 6. So if you want to rearrange it in the descending order of the powers, then it will be minus x to the power 6 first. And then plus, you can write it as 1 by 5 x cubed minus 7 by 2 x squared plus 2 by 5 x plus 1 by 5. We have arranged the terms in the descending order of the powers of x. We have arranged the terms in the descending order of the powers of x, big to small. Minus x to the power 6 you can write x cubed by 5 as 1 by 5 x cubed minus 7 by 2 x square plus 2 by 5x plus 1 by 5. Children, I can tell this again. If I'm not clear, please tell me. I'll do it again. Is this understood by all?
Yes, ma'am.
Okay.
Yes, ma'am.
All right, children. So this is how. So this is the given polynomial. This can be better understood when you represented it like this. This one can be better understood when you put it in this form. And Leslie was right. She said the degree of the polynomial is 6. So first, the answer to the first question, degree. Degree is 6. Correct. Second one, the coefficient of x cubed. Abhishek, what is the coefficient of x cubed in your book? Not from the screen. What have you written? Have you written 1, Abhishek?
Ma'am.
The coefficient of x cubed, have you written 1?
No, ma'am.
Okay, if you, children, if you have written the coefficient of x cubed as 1, please understand it is wrong. See, if you look at x cubed here, the coefficient is 1. If you've written this answer, you're wrong. It is not 1. It is 1 by 5 plus 1 by 5. Disable your mic. The coefficient of x cubed, the coefficient of x cubed is, see here, you must write it in this form to understand the coefficient like this. What is the coefficient of x cubed? Plus 1 by 5 or simply 1 by 5. If you have tried to write the coefficient from the given polynomial, like in this form. See it here. This is x cubed, its coefficient is 1. It's wrong. See, sometimes, you might have more than one x term or x square terms or x cube terms. So then you'll have to simplify. That's what I told you. When you're given a polynomial, and if it is possible to simplify or express it in a better way, do that first and then answer the questions. If you're given a polynomial, which can be simplified further, or which has to be presented with the terms in the correct order, like here. Like here, we have to present the terms in the correct order to understand the polynomial better, to answer the questions correctly. Do that first and then answer the questions. Somebody's mic is enabled. Please disable your mic. So this is very, very important. Writing the given polynomial in this form is very, very important to answer the questions based on the polynomial correctly. If you want to simply answer it, you can use this. But if you want to answer it correctly, you have to use this. The coefficient of x cube is 1 by 5. Then the coefficient of x to the power 6. The coefficient of x to the power 6. The coefficient of x to the power 6 is what, children? What's the correct answer?
1 by 5.
Laksha, how is it 1 by 5, Laksha?
The
What
minus
is
1.
Minus 1.
Minus 1. Minus 1. The coefficient of x to the power 6 is
I
minus
answered
1.
the second one.
Sorry, you answered for?
Second question, ma'am.
Okay, fine. The coefficient of x to the power 6 is minus 1. And the last one, the constant term. Which is the constant term?
1 by 5.
Yeah, plus 1 by 5 or simply 1 by 5. If it's minus, you have to write minus. If it is plus, you can just write 1 by 5 also, or plus 1 by 5. Both are correct. It's 1 by 5. So I told you sometimes the polynomial may have more than one x term, more than one x square term. Then you have to add them. Like terms must be added. Meaning like terms must be simplified. So whenever simplification is needed, you'll have to do that and then answer the questions based on the polynomial. Okay. A few questions in question number 1 we'll discuss and wind up the session. So this one, 1 by 2x. 1 by 2x is nothing but 1 by 2 into 1 by x. 1 by 2x is nothing but 1 by 2 into 1 by x. And this is nothing but 1 by 2 into x to the power minus 1. You must always look at the power with the variables in the numerator, not in the denominator. The variable should not lie in the denominator. If it is in the denominator, take it up to the numerator and then read the power. So 1 by x, 1 by x, the power is 1, which is a whole number. No, don't read it like this. 1 by x is x to the power minus 1. So now here again, we are not concerned about 1 by 2. We are only concerned about the variable and its power. This is the variable. This can be anything. This is the variable. And the power is minus 1, which is not a whole number, It's not one of these numbers. So 1 by 2x is not a polynomial. It is not a polynomial. But you can see in subdivision 4, you have 1 by 5 x to the power minus 2. In subdivision 4, 1 by 5 x to the power minus 2 plus 5x plus 7. Now, this is nothing but 1 by 5 into 1 by x to the power minus 2. See, you should show all the steps till we understand things correctly. Sometimes, we'll miss 2 steps and try to write the final step. You won't realize that you have not understood clearly, but you might be writing it correctly. So you believe that you have understood, but actually you might have not understood clearly. Always split like this and write till we understand. So 1 by 5 x to the 1 by, it's not 1 by 5, it's 1 by 5x to the power minus 2. It's 1 by 5x to the power minus 2. It's nothing but 1 by 5 into 1 by x to the power minus 2. Then plus 5x plus 7. Now 1 by 5 as it is. X to the power minus 2 is when it goes up to the numerator. This one in the denominator, when it's it becomes this positive. The sign changes. If it's plus, it becomes minus. If it's minus, it becomes plus. When you take it up to the numerator, it becomes x to the power plus 2, plus 5x plus 7. Now it's time to look at the variables and their power. X power 2 whole number, x power 1 whole number. So here the first term has the variable x, the second term also has the variable x. The power is 2, which is a whole number. The power is 1, which is a whole number. So this one is a polynomial. This one is a polynomial. The variables must always be, see then the constant. Now don't ask me why you're not taking 5 to the numerator. We're not worried about the constants. The variable should be in the numerator. You must read the power of the variable with the variable in the numerator, not in the denominator. Supposing you have x by y to the power minus 1. X by y to the power minus 1. This is nothing but x into 1 by y to the power minus 1. Don't read the power of y with y in the denominator. Take it to the numerator. So it will be x into y to the power 1, which is nothing but xy. Now tell me, is xy a polynomial? Is xy a polynomial?
Yes, ma'am.
Yes, because the power of x is 1 and the power of y is also 1, both of which are whole numbers. Now, based on the number of terms, give a special name to the polynomial xy. Based on the number of terms, it's a
Monomial.
Monomial. It's a monomial because x plus y is a binomial. Xy is a monomial. XYZ is also a monomial. A, B, C, D, E, F, G is also a monomial. If I write A plus B plus C plus D, then it is a polynomial with 4 terms. Then it is a polynomial with 4 terms. If I write A plus B plus C, it is a polynomial with 3 terms, which is a trinomial. If I write A plus B plus C plus D plus E plus F till Z, then it's a polynomial with 26 terms, 26 different variables. It's a polynomial with 26 terms. But if you write A, B, C, D, E, F, G, H, I, J, K like this till Z, it's a monomial. It is a monomial because the signs separate the terms. XY is only one term, but X plus Y, 2 terms. Plus is the separator. Plus and minus are the separators. You must have seen this in standard 8. Plus and Y are the separators. XY is only one term. X plus Y or X minus Y, 2 terms. Because plus minus separator. So this one is a monomial. This one is a monomial. It is a polynomial with only one term. So it's a monomial. What's the degree of this polynomial, children?
1, ma'am.
1, ma'am.
1, ma'am.
It's 2, ma'am, because it has 2 different variables.
Yeah, it's not 1. It is 2 because the power of X is 1. The power of Y is 1. This is one term. In this term, we have 2 variables, X and Y. So we have to find the sum of the powers. 1 plus 1, 2. So it's a quadratic polynomial. See, now if you have 5xy plus 7, this is one term, this is another term. So in this term, you have 2 variables, X and Y. So add the powers, 1 plus 1, 2. So this one is a quadratic polynomial because its degree is 2. Its degree is not 1, its degree is 2. It's quadratic in 2 variables Y. So when you look at this expression, this one is an algebraic expression. It is also a polynomial. It is a monomial. It is a monomial. It is a quadratic polynomial. It's a quadratic polynomial, xy. Xy is an algebraic expression. Xy is a polynomial. Xy is a monomial because it has only one term. And xy is a quadratic polynomial because its degree is 2. When you look at 5xy plus 7, or plus 5xyz plus 7. This one is an algebraic expression. This one is a polynomial. This one is a what? Monomial, binomial, trinomial.
Binomial.
Binomial. It's a binomial because it has 2 terms. 5xyz is one term and 7 is the other term. It's a binomial. And what's the degree?
Cubic.
Yeah, the degree is 3, so it's cubic. 1 plus 1 plus 1. The variables x, y, z. Their powers 1, 1, 1, 3. 3 meaning cubic. It's a cubic polynomial. It's a cubic polynomial. So it's an algebraic expression. It is a polynomial. Based on the number of terms, it's a binomial. And based on the degree, it is a cubic polynomial. I'll let you know. Fine, we'll continue on Tuesday at the center. Yeah. So maybe you have to have your breakfast if you have not finished in the morning. So finish your breakfast and share the pictures on WhatsApp with me. That's very, very important. Do not forget. Even if you worked only 1 or 2 sums, I want to see that. So based on the mistakes you have made, I will be able to explain better in the next class. When we continue in the next class, I'll have a look at all the working. So then the mistakes, if any, will be in my mind. So based on that, I'll try to explain better in the next class. Not that I didn't do it well today. So based on the mistakes you have made, I'll understand that these things have to be clarified. So I will try to make it more clear with more examples in the next class. All right. Fine, children. Thank you so much for making it up in the morning. And yeah, some of you have not attended. Some of you messaged that there's no power in your area, so you don't have access to the internet. Fine, I'll share the recording. All right, children, thank you so much once again. That's it for today's session. You may leave the call.
Thank you.
Have a nice day.
Ma'am,
Have a
I
nice day.
understand the
Thank you, ma'am.
Thank you, children. Have a nice
Thank
day. Thank you.
Thank you, ma'am.
Thank you, children.